everyone. I'm going to write it down. So this is problem 4. Okay, so we have R, which is 0.488, because they are telling us something very important. It's a linear correlation coefficient. Only because of that, and R is given to us, what I'm going to do is square 0.488, and I square it, and I get 0.23. So then R is 0.23811. Of course, R squared. Okay, which means 23.811% is explained, a variability in the y values in the response variable is explained by the linear regression, least squares linear regression line. So I will not even look at these two because I already determined that R squared, the coefficient of determination, is 0.238. So I'm looking at the last two. 23.8% of the variation is explained by the linear correlation, and 76 is explained by the other factors.
I think it's that one.
Yes, because this is completely opposite. Good. Then we wanted to look at number 7. Okay. A is a scatter diagram with the residuals on the vertical axis and the explanatory variable on the horizontal axis. Remember, that is called the residual plot. So let's look for the residual plot. Box plot of residuals? No. Least squares regression line? No. Histogram? No. It's residual plot. The y-axis has residuals and the x-axis has the explanatory variable. Okay, then we wanted to look at problem 9. I see a pattern in the residuals. Residuals on the y-axis and the explanatory variable on the x-axis. Obviously, I don't even need to read the problem. Well, of course, we are going to read it. Analyze the residual plot below and identify which, if any, of the conditions for an adequate, right, the constant error. Which of the conditions below might indicate that a linear model would not be appropriate? The constant error variance. So that is, and also which of the conditions below. So I don't know if it allows me to select more than one. No, it does not. So which of the conditions below might indicate that a linear model would not be appropriate? Constant area variance. But at the same time, it's a patterned residual. I see a pattern in the residuals. So analyze the plot and identify which, if any, of the conditions for an adequate linear model is not met. So, but pattern and residuals is the same. Yeah, its interpretation, it's tricky, but both of them are correct. So they should not put them together because the constant error variance is violated. So careful with that answer, with that question. So question 10 was the next. Okay, the following data represent the time between eruptions and the length of eruption for 8 randomly selected geyser eruptions. Okay, complete parts A through C below. What type of relation appears to exist between time between eruptions and length of eruptions? Okay, so let's look at the scattered. It appears to be a linear positive association. Does the residual plot confirm that? I don't know. Okay. So, interesting residual plot.
What's that blue line supposed to represent?
Say it again.
What's the blue line supposed to represent?
Very good. Very good. The residual, very good. Let me explain that. Excellent question. Excellent question. Okay. So every time, I can even go back here. Every time we plot the residuals, remember residuals are positive, 0, and negative. We're not plotting the residuals squared, so all numbers will be positive and negative. So this line is when the residuals are 0. So this point has a residual that is negative, this point has a residual that is positive, this one has a residual that is negative, and so on and so forth. So this is the line that shows which points have positive residual and which points have negative residual. Very good question. Is that okay?
Yep, thanks.
Thank you. Very good question. Okay, so kind of looks all over the place. There is no real pattern to speak of. So, does the residual plot confirm that the relation between time between eruptions and length of eruptions is linear? The plot of residual shows a discernible pattern. Not really. The plot of the residuals showed no discernible pattern, so a linear model is appropriate. I still want to read the other two. The plot of the residuals shows no discernible pattern, implying that the explanatory and response variable are not linear. No. The plot of the residuals shows that the spread of the residuals is increasing. No, no, no. So the residual shows that these are implying that, yeah, I will go with B. The coefficient of determination is found to be this. So this is R squared already and percent. Provide an interpretation of this value. Anyone would like to give it a shot?
Would it be 7.9 or 6.9?
So the least square regression line explains how much of the variation?
Is this the one where we're taking it out of 100%?
But this is the coefficient of determination is the one who explains. So this is indeed 93.1
Okay.
of the variance. It has to be the y value. Okay? So now what was the y? It was the length of eruptions. Time is x, length is y. So it's in the y variable. Length of, because you remember that analysis is only for the y variable, and y is the length. So this was 10. Then you selected 13. Okay. A residual plot from a simple linear regression analysis is shown to the right. Use the plot to answer the question below. Okay. Which of the following statements regarding the plot is true? I do see a pattern. So as x increases from this value till this value, they go higher positive or lower negative, and then as x increases, it gets, so I see like a rectangular shape, rhombus shape, something. I see some sort of pattern here. The condition that the residuals are normally distributed is not met. The condition that the residuals have constant variation is not met, since the variation increases and then decreases as x gets larger. So I agree with B. The condition that the residuals are normally distributed is not met, since the residuals fall, and the condition that the residuals have constant variation is met. No. Since the lines connect, no. So the condition that the residuals have constant variation is not met, since the variation increases and then decreases as x gets larger. Because I see a pattern here. And you also selected 15. When is a point influential? Very good question. I'm going to stop sharing for a second. So as we talked about mean and median, etc., etc. Similar situation we have here. So here's the cloud. And here's a point. If I disregard this point, then I will say this is a positive linear correlation, quite strong because the cloud is compact, they are clustered together. When I look and say, oh, there is one here, and remember the regression line will the best fit the least squares regression line, where the minimum residuals will be like this. But now, this linear regression line, if this is a legitimate, not a mistake, if this is a legitimate point in the data set, look what will happen. It will skew the linear regression line quite a lot. So y hat equals b1x plus b0 versus this one will be different. Very different. So back sharing. So if it has high leverage, when omitting the observation would result in a very different, yes. It has a high residual. When it is from a different population, then no. So an influential point, or when is a point influential? Say it again.
I think it's B.
Yes, because when omitting the observation result will be very different in the regression equation. Yes. Thank you.
Can we do question 11?
Yes. Let's take a look at 11. Good. So the time it takes for a planet to complete its orbit around the particular star is called the planet's sidereal year. Okay. The sidereal year is a planet is related to the distance the planet is from the star. Fine. The accompanying data show the distances of the planets from a particular star and their sidereal years. Complete parts A through E below. Okay, draw a scatter diagram. I have no idea how this will look like. I can't choose anything before I look. Okay, and I can do the scatter plot here. And of course, I need the distance, I need the year. And that should be good enough. Okay. So back to the problem. So obviously it appears to be B. Good, thank you. Determine the correlation between distance. Okay, so it's the correlation coefficient they mean. Okay, so let's see, where is my... Okay, it disappeared on me again. Never mind. I have to do it again anyway because now I'm looking for something else. Okay, so I want the regression, simple. I select this, and who knows, probably you're going to ask us to predict something anyway. So I'm going to write it down. So the correlation coefficient are 0.9885472, R squared 0.97722, I'm going to copy y hat 0.0654658, x minus 12.5030. Do I need anything else? No, I'm going to have to come back because I'm sure they're going to ask us to predict. Okay. Oh, no, I didn't mean that. Okay. So the correlation coefficient is 0.98, they want 3 decimal places. 0.989. Okay. Then does this imply a linear relation between distance and sidereal ear? Yes or no?